So, kids, tomorrow I will take your class test on balancing the chemical equation. Be prepared.
Okay, ma'am.
Hi, Samir.
Hi, Sania. Where were in the last lecture?
I got late. What was done?
Miss Lisa told. She will take the test of balancing chemical equation tomorrow.
Oh shit. I was even absent for that lecture too. Kindly help me with it. Please, please, please.
Okay, meet me online today evening.
Thanks.
Later in the evening.
Sania. I will share my screen and do all of it. I want you to note down and practice to score good.
Sure, Samir. This is my last chance to score.
Let's begin.
Screen sharing.
We are going to learn how to balance a chemical equation. So for that, we need a chemical equation which is here. This is the first one, and like that, I'll be teaching you around 25 of them, and we'll check whether the given equation is balanced or not. If not, then how to balance it. So let's start with the chemical reaction. Before we begin with the checking whether it is balanced or not, we need to understand the term that the element present on the left hand side are known as your reactant, and what we get on the right hand side in the chemical equation is called as product. So once you are aware of this reactant and product and the side where are they present, it becomes very easy for us to start with the chemical reaction. So for that you need a table somewhat like this initially, but once you are expert in it, it's up to you if you want to use it, or without using it also you can write the chemical reaction. So let's start with the element involved in the chemical reaction. The first element which you can see over here is hydrogen, and the second is oxygen. So I will write the element in the table as hydrogen and second one as oxygen. Later on, even we need to see the number of atom of hydrogen. Now over here, there are how many atoms of hydrogen? There are 2 atoms of hydrogen. On the reactant side, there are 2 atoms of oxygen. But on the product side, we have 2 atoms of hydrogen and there is no number with oxygen. So when there is no number means what it is? It is 1. Now why we have taken this all? Because we are going to put this numbers into a table. So let's start. On the reactant side, how many hydrogen atom? 2. So I'll put 2 here. On the product side, how many hydrogen atom? It is 2. So I'll put 2 here. On the reactant side, how many oxygen atom? It is 2. So I'll put 2 here. On the product side, how many oxygen atom? It is 1. So I'll put 1 here. Once you place them all, it will help you to understand whether your given balance chemical equation is balanced or not. How? Let's check. Check this hydrogen. On the left I have 2, on the right I have 2. It seems it is equal and balanced. But when I come to oxygen, on the left I have 2, but on the right I have 1. Is it balanced? No. So oxygen is not. So this reaction is not a balanced chemical equation. So how to balance this? So for balancing part, what can be done is, we need to see which one to change first. So when you go for this one, like hydrogen seems to be already balanced, so we'll not touch hydrogen. But oxygen, as I have 2 here, I have 1 here. So can I make this 1 as 2 by simply multiplying it with 2? So for this, what am I doing? I am multiplying 2. To which element? To oxygen. On which side? On the product side. So go and check the product side above. If you see, oxygen is not alone over here. It is combined with hydrogen. So where should I put this 2? Should I put it 2 at the end? No, it will go wrong. Then where should I put this 2? So for that, you need to put this 2 ahead. Once you place this 2 ahead, this 2 gets equally distributed to both of them. Which means your oxygen got balanced, but because of this extra 2 which you have placed here, your hydrogen got unbalanced. How? Now this 2 and this 2. So 2 to the hydrogen becomes how much? 4. So earlier the hydrogen was 2 on the product side, but now it becomes 4. Okay, when it becomes 4, it gets unbalanced. As we have 2 here, 4 here. So to balance this, what am I going to do? I am going to multiply this one also by 2 because 2 to the will become 4. So now I'm multiplying 2 hydrogen on which side? On the reactant side. So go to the reactant side. As you go to the reactant side, do we find hydrogen alone here? Yes. So I can simply put 2 there. It becomes very easy. So once I put 2 here, now come down. Let's see 2 with this 2. And let's check out that whether the reaction is balanced or not. Because I have 4 and 4 here. I have 2 and 2 here. Same way you can see 2 to the 4 hydrogen atom, 2 to the 4 hydrogen atom, 2 oxygen atom, and this 2 on the 2 oxygen atom. Hence the reaction gets balanced. Reaction chemical equation, we are also going to balance this. So we have the next one over here as Mg, that is magnesium plus oxygen gives magnesium oxide. So we are already aware of the things, so directly we are going to put this into a table that which all elements are involved. So the element first is magnesium and the second one is oxygen. The number of magnesium atom, there is no number, means 1, so I'm going to write on the reactant side it is 1, and on the product side also there is nothing, means 1. Same way oxygen on the left hand side it is 2, and oxygen on the right hand side there is no number, means it is 1. Now we'll see whether the given equation is balanced or not. So when you see magnesium, it seems to be balanced as 1 and 1. But what about oxygen? Is it balanced as 2 as 1? It is not. Okay. So we need to balance this oxygen first. So balancing the oxygen first, what am I going to do? I'll check. But how can I make this 1 as 2? So in order to make this 1 as 2, I'll just multiply this by 2, so that it becomes 2. So I'm multiplying 2 to which element? To oxygen. Again, on which side? On the product side. But as I go up, do I find oxygen separate? No, it's combined. So I'll put 2 for both. The moment I take 2 for both, this 2 gets equally distributed. So even it will go for magnesium as well as for oxygen. Now oxygen got balanced as 2 and 2. But what about magnesium? Earlier it was 1, but because of this extra 2 which is just placed now, it got changed from now 1 to 2. Because of which even magnesium got unbalanced. Look at the reactant and the product. We have 1 and we have 2. But is it easy for us to make this 1 as 2 by simply multiplying it with 2? So I'm going to multiply now oxygen by 2. On which side? On the reactant side. Do I have oxygen separate over here alone? Yes, I'll simply put 2 there. The moment I put 2 there, the reaction seems to be balanced as 2 and 2, 2 and 2. Let's see. Let me write the reaction again. It becomes 2 and 2. Let's check out. Magnesium was 1, 1 and 1. Now this 2 is for this. So 2 on the 2. How many magnesium atom? 2 magnesium atom. 2 on the 2 again 2 magnesium atom. Oxygen was already 2, but here it was 1. So now 1 to the 2. It seems everything is balanced. For chemical reaction, wherein we are going to start with the element involved. So we have sodium as one of the element and oxygen as the other. Now see, let's see the number of atom of sodium on the reactant side. So we have here 1. So I'll put 1. On the product side, the number of atoms of sodium is 2, so I'll put 2. Same way, oxygen on the reactant side is 2, so I'll put 2. And here there is no number, means it is 1, so I'll put 1. Now, we will check whether sodium and oxygen is balanced or not. So if you check the sodium, we have 1 and 2. Is it balanced? No. Likewise, oxygen is also not balanced. So to balance them, we are going to start with the multiplication. So I feel I should go with oxygen first, because and we have seen so many so far. So I will multiply 2 to the oxygen. When I multiply 2 to the oxygen on the product side, I get it as balance. So on the product side, when I go up, there is oxygen is combined with sodium. So I'll have to take 2 for both of them. Once I take 2 for both of them, what do I find? That this sodium, which was only 2, now gets changed as 2 to the 4. So oxygen got balanced, but sodium did not. So in order to balance sodium, I have 1 and 4. I'll multiply this 4, multiply 1 by 4 so that I get it as balance. So I will be multiplying 4 to sodium on which side? On the reactant side. So on the reactant side, do I have 4 sodium alone? Yes. I'll put 4 there. So what I got finally as 4Na plus O2 gives 2Na2O. Let's check whether the reaction is balanced or not. So earlier we all know that it was 1. So how many atoms of sodium? It is 4. How many atoms of sodium? 4. How many atoms of oxygen? 2. How many atoms of oxygen? It is 2. Hence the reaction is balanced. So this is your balanced chemical equation. Now we have potassium. Let's check whether the given reaction is balanced or not, and if not, then how are you going to balance this? So first of all, we are going to write the element involved. One of this is potassium and the other one is oxygen. Now we are going to write the number of atoms. So on the reactant side, the number of atom of potassium is 1, and on the product side, the number of atom of potassium is 2. Similarly, we'll also write for oxygen. On the reactant side, the atoms are 2, and there is no number, means it is having 1 atom of oxygen on the product side. Now we are going to check whether potassium is balanced or not. As we can see, 1 and 2, so it is not. Similarly, 2 and 1, even this is also not. So both of them are not balanced. In order to balance, first I am going to multiply this oxygen by 2. So once I multiply oxygen by 2, I get 2. So I am multiplying 2 to the element oxygen on which side? On my reactant side. But as I go up and see, on the product side, I don't have oxygen alone. It is combined. So still I'll put this 2 for both. Now when I put this 2 here, so potassium, which was 2 earlier, now becomes 2 to the 4. So it gets changed to 4, and oxygen becomes 2 on the 2. So oxygen gets balanced, but potassium did not. So in order to balance potassium, as I have 1 over here, so what I can do is I can simply multiply it with 4, right? So when I multiply 4 to the element potassium on the reactant side, now when I go on to the reactant side, do I find potassium alone? Yes, I need to multiply it with 4. Once I put as 4, so what do I get finally? As 4K plus O2 gives 2K2O. Now let's see, the number of atom potassium on the reactant side is 4, but on the product side is also 2 to the 4. Oxygen on the left is 2, and oxygen on the right 2 on the 2. Hence the reaction is balanced. And this is how we can balance Cl2 gives FeCl3. Let's start with this and check whether the given reaction is balanced or not. So I will be putting the element in the table. One of the element is Fe and the other one is Cl. We'll also put the number of number of atom on the reactant side. So Fe on the reactant side, as there is no number, means there is 1. On the product side, again there is no number, means there is 1. So I'll put 1 and 1. But when I see the reactant side, chlorine, the number of atom is 2, and on the product side, the number of atom is 3. Let's check whether Fe is balanced or not. If you see Fe, it seems to be balanced as 1 and 1, but chlorine is not, as we have reactant side 2 and the product side as 3. So Fe balanced, chlorine not. How will you balance? In the previous examples, we were having the even numbers, but here the numbers are not even. Like we have 2 and 3. So to make 2 as 3 is difficult, and even 3 as 2 is not possible. So in this case, what we are going to do is we are going to take the LCM of these two numbers. So if you check the LCM of these two numbers, what do you find the LCM of 2 and 3? It comes as 6, which means I will be multiplying 2 by 3 and 3 by 2. So I will be multiplying both the sides these numbers. So I am multiplying 2 chlorine on my product side, but again the chlorine is not alone above, it's combined, but still I'll put this 2 to both of them. The moment I put this, so it becomes 3 to the 6. Now at same time this 2 is equally for both, so the Fe which was 1 earlier now changes to 2. Similarly, when I multiply 3 to my chlorine again on the reactant side, it becomes 6. On the reactant side, do I have chlorine alone? Yes, I'll put directly as 3. When you check now, chlorine seems to be balanced with number as 6 and 6, but Fe is still not balanced because we have 1 and 2. So we all know making 1 as 2 is very simple by just multiplying it with 2. So now I'm multiplying 2 to Fe on which side? On the reactant side. Do I have Fe alone above? Yes, I'll put 2 there. And even the Fe gets balanced. So what is the final number? The coefficients are 2 Fe plus 3 Cl2 gives 2 FeCl3. Let's check the number of Fe atom on the reactant side is 2 ones are 2, and the number of Fe atom on the product side is 2 ones are 2. Same way, number of chlorine atom on the reactant side is 2 3s are 6, and on the product side is again 2 3s are 6. And the reaction is chemical equation as we have H2 plus Cl2 gives HCl under the sunlight. Let's check. The element involved is H, hydrogen and chlorine. Now we are going to write the number of atoms. On the reactant side there are 2 atoms of hydrogen, and on the product side there is nothing, means there is 1 atom of hydrogen. Similarly chlorine, here it is clearly 2. On the side, right hand side, product side where there is no number, means it is 1. It's very clear that both of them are not balanced, as we have 2 1 2 1. So to balance this, we are going to multiply each one of them. Right, so let's start with chlorine. As I have 1, and we all know making 1 as 2 is very simple, just multiply it by 2, it becomes 2. So I'm multiplying 2 to which element? To chlorine. On which side? On the product side. As we go up, again chlorine is not alone, it is in the combined form. So I'll put this 2 commonly for both of them. So chlorine gets balanced as 2 and 2. What about hydrogen? Here it was earlier 1 and now 2 ones are 2. So earlier it was 1 and now 2 ones are 2. Now let's check on the reactant and the product side. Even the hydrogen got balanced along with chlorine. So I need to put this numbers down, as we have H2 plus Cl2 gives 2 HCl, wherein you can check 2 atoms of hydrogen, 2 atoms of hydrogen, 2 atoms of chlorine, and again 2 atoms of chlorine. Hence the chemical equation is nitrogen reacting with oxygen to form NO, that is nitric oxide, at 3000 degrees Celsius. So how are you going to balance this? Let's start. The element involved is nitrogen and oxygen. The number of atom of nitrogen on the reactant side is 2, and on the product side as nothing, means 1. Same way, oxygen side, it is again on the reactant side oxygen atom is 2, and on the product side nothing, means 1. When we compare these two, we found that both this nitrogen as well as oxygen is not balanced, as we have 2 1 and 2 1. So we can balance any one of them. Let's start with oxygen. So to make 1 as 2 is quite easy, just multiply it by 2. I have multiplied 2 to which element? To oxygen. On which side? On the product side. But as I go up, I find oxygen again is not alone. It is in the combined form with nitrogen, so I'll put 2, which is common for both now. So oxygen gets balanced with 2 and 2, whereas this 2 will also bring the change in the nitrogen atom, as 1 2 the 2. Earlier it was 1 and now it becomes 2. And when you see, even the nitrogen gets automatically balanced with 2 and 2. So what will be your final reaction? N2O2 gives 2NO. Let's tally this. 2 atom of nitrogen on the reactant side, 2 atom of nitrogen on the product side. Same, 2 atom of oxygen on the reactant side, 2 atoms of oxygen on the product. Hence the reaction equation balance, where we have N2 reacting with H2 in the presence of catalyst Fe, which is heated up to 450 degrees Celsius and at a 200 atmospheric pressure, which results into ammonia, and this plus delta. Now this plus delta, this is the symbol which is used for heat, right? Any equation which results into heat, where the heat is given out, is indicated with this delta, and such reactions are known as exothermic reactions. Let's try to check whether the things given equation is balanced or not. So we have the first element as nitrogen, second as hydrogen. Now the number of nitrogen atom on the reactant side is 2. Number of nitrogen atom on the product side is 1. Number of hydrogen atom on the reactant side is 2. Number of hydrogen atom on the product side is 3. When we compare the left reactant and the product side of each one of them, we find they are not equal. It means nitrogen is also not balanced, even hydrogen is also not balanced. In order to balance, we can take any one. So let's start with nitrogen first. I know that if I want to make this 1 as 2, I just need to multiply this by 2. If I multiply this by 2, it becomes 2. So now I am multiplying 2 to which element? Nitrogen. On which side? On the product side. But as I go up and check, I don't find nitrogen alone. It's combined. So I will put this 2 for all. So once I take this 2 for all, in that case, this nitrogen gets balanced easily, S2S2. But this 2 will also go for hydrogen and will bring the change in the hydrogen atom. Earlier there were 3, but now it will be 2 3 the 6. So now I have 2 on my 2 atoms on the reactant side, 6 atoms on the product side. But it is very easy for me to make it as 6 just by multiplying it with 3. So now I am multiplying 3 to hydrogen. On which side? On the reactant side. As I go up, do I find hydrogen alone? Yes, I just need to put 3 there. Once I am done with that, now just put the reaction as 1 NH2, 3H2, and here it will be 2. Now just let's tally this. Nitrogen atom are 2 here, and this also makes it as 2, which is balanced. 2 3 the 6 hydrogen atom, 2 3 the 6 hydrogen atom, which is balanced. Hence the chemical reaction is balanced in this. Like previous reaction, we are going to take one more chemical reaction over here, which is having sulfur dioxide reacting with oxygen in the presence of a catalyst as V2O5, which is heated up to 450, resulting into sulfur trioxide, and this plus delta, which indicates that the given reaction is exothermic reaction. Now let's go to balance it. We'll check the element involved. So one of the element is sulfur and the other one is oxygen. Now the number of atom of sulfur on the reactant side is 1, so I'll just write 1. The number of atom of sulfur on the product side is also 1, so I'll write 1, which seems to be balanced. Now the number of atom of oxygen, as there are 2 oxygen here also 2, here also 2. So what we are going to do is we'll take 2 plus 2, which means what it is? It will be equal to 4. And on my product side I have only 1, that is 3. In this reaction, sulfur seems to be equal, but oxygen is not. So if you want to start with oxygen, you can go with it. You need to go with the LCM and all, but it will be a lengthy process. I'll just share a shortcut, a very small trick. You can go with that too. Instead of going with the LCM, just double this up. Now we all know already it is balanced, but multiply it by 2 on both the sides. So once you multiply them both the sides, still their sulfur is still balanced. So what I will write is I have multiplied 2 to which element? To sulfur. On which side? On the product side. But as I go up and see, sulfur is not alone, right? It is in combined form, so I'll have to put this 2 common for both. As sulfur was 1, now this common 2. So sulfur 2 ones are 2. Sulfur became 2, which is balanced. And what about the oxygen? It also changed the oxygen. Oxygen was 3, now 3 to the 6. So earlier it was 3, now it became 6. Similarly, when I multiply 2 sulfur on the reactant side, do I have it sulfur alone? No, still it is in combined form. But as I have already taken 2, I need to put 2 there. Once I take 2 there, my sulfur becomes 2. 2 1 the 2. What about the oxygen? 2 to the 4. And here it was 2. So 2 plus 4 together, it automatically changes to 6. If you check now, sulfur is balanced with 2 and 2. Oxygen is also balanced with 6 and 6. So hence both are balanced. So what is my final tally? That I will write the chemical equation as 2SO2 plus nothing as 1O2 gives 2SO3. Now if you want to tally, you can tally the sulfur atom on this side is 2 1 the 2. Even sulfur atom on this side is 2. Both are balanced. Oxygen 2 to the 4. This 2 together on adding it becomes 6. Same way 2 3 the directly 6. Hence the chemical equation is balanced. Take one more chemical reaction, which is mercuric oxide decomposes to mercury and oxygen. Now let's see whether it is balanced or not. So the element is mercury and the other element is oxygen. On the reactant side, the number of atom of mercury is 1, so I'll write 1. On the reactant side, it is also 1. Product side, so it is 1, which seems to be balanced. Oxygen on the reactant side is 1, so I will write as 1. Oxygen on the product side is 2, so I will write 2. When we compare reactant and the product side, for mercury it is 1 and 1, which seems to be balanced. But oxygen is not, as we have 1 and 2, so it is not balanced. So we need to balance this. And we all know that the balancing is quite easy now. I hope by now you must have learned it. Just make this 1 as 2 by multiplying it with 2, it becomes balanced. So for that I am multiplying 2 to which element? Oxygen. On which side? On the reactant side. Let's go up. Do I have oxygen alone? No, I have it in combined form, but still I'll put 2. The moment I put 2, this 2 goes for both, so it also changes mercury. Earlier mercury was 1, but now 1 to the it becomes 2. Oxygen gets balanced, but because of this mercury got changed to from 1 to 2. Now I have product side as 1, so now I will put this as 2. So I will multiply 2 to mercury on the product side. So do I have mercury alone on the product side? Yes, I'll just put 2 there. Once I'm done with that, now let's tally. It will become 2HgO plus 2Hg. Let's tally now. Mercury 2 1 the 2. Mercury 2 1 the 2. It's balanced. Oxygen 2 1 the 2. Oxygen already 2. Now both are balanced. Hence the chemical equation is balanced.
Screen sharing stopped.
I think your doubts must have got cleared. And this much is enough for now. Hope so. You practice and score. All the best, Sania. See you tomorrow.
Thanks you so much, Samir. Bye. Good night.